Emostel.
Hello, you're welcome to Emostel Academy again, and your usual host, Emostel Academy. All right, today in this video in Mass 103, we are going to be talking about something that is looking a little bit advanced, but not so much anyway. It's still simple, okay? We call it the dot product of two vectors. Actually, when it comes to product of vectors, we have done addition of vectors. That is when two vectors add up to each other. All right, so for us to get a resultant vector of the two of them, all right, okay, we've treated that one. But this time around, we are talking about product of two vectors. In mathematics, product means multiplication. All right, so there are two types of it that we have in vectors. We have the scalar product and we have the vector product. Another name for the scalar product is called the dot product, and another name for the vector product is the cross product. In this video, we will lay emphasis on the dot product, which is the scalar product. All right, let's go. Now, let's assume a vector is like this and another vector is like this, and we have an angle theta between the two of them. All right, so generally the formula given for the dot product of two vectors is the magnitude of the two vectors multiplied by cos theta, where theta is the angle between the two vectors involved. How this formula was gotten is not something I'm so much interested in discussing because of time factor, but then everything is easy, okay? But just to understand for the scope of this class that the dot product of two vectors is given as magnitude of vector A multiplied by magnitude of vector B, then multiplied by the cosine of the angle between the two vectors. All right, so, and then look at this clause here, non-zero. Non-zero means none of the vectors must be a zero vector. All right, for us to be able to get the scalar product or the dot product of the two vectors. Okay, none of the two vectors must be a zero vector. Please take note of that condition. All right, so we move into this place. Provided that we have two vectors, A and B, represented in their component form like this. So the X component, the Y component, the Z components with the I, the J, and the K, provided that we have this scenario. All right. After some kind of calculation or proofs on this and that, it's been derived that the dot product of two vectors represented in this manner is equal to the product of the components, the sum of the products of the components. So, which means the components of the X components for vector 1, we multiply the X components of vector 2, vector A, the X component of, pardon me please, the X component of vector A will multiply the X components of vector B. All right, then you add the result to the Y components of vector A, the Y components of vector B, you add the result to the Z components of vector A and the Z components of vector B. And then when you do that, the result is the dot product of the two vectors. All right, so like I told you, I'm not really so interested because of time factor. This class is meant for exam. So how this formula was derived and all of those things, I don't think that should be your business for now. All right, but just understand the fact that when the question demands you to find the dot product of two vectors, depending on what the question provides, If the question provides an angle and then an angle between the two vectors and all that, or the question wants you to find the angle between two vectors and they give you this component, then come and apply this formula and then you'll be able to get the angle between the two vectors. We are going to get there, okay? Let me just explain, then we do a few examples. We play around a few examples as usual, okay? So just get the scope that the dot product of two vectors is this. Then it is important to know, so now we have two different formulas depending on what the question provides. This formula and this formula are correct for looking for the dot product of two vectors. So whichever formula you now decide to use depends on what is being given to you in the question. You understand? So we are going to play with some questions, then you will see how these formulas can be applied. All right, we move. It is important to note the following. Number one, the dot product of two vectors reaches its maximum value when both vectors are parallel. When we say two vectors are parallel, it means there is no angle formed between them. We are talking about vectors like this, okay? No angle formed between the two of them. They are totally parallel. If one vector is like this and another vector is like this, we don't consider them being parallel. You know why? Because if there is an extension and an extension, eventually they will meet at a particular angle. All right? But when you say two vectors are parallel, this one they are not parallel because they are like this. If you extend, they will eventually meet. Parallel means they are totally parallel. They can be in any direction, but no matter how you extend the two lines, they will never meet. So vectors like that or lines like that are parallel vectors. They're called parallel vectors. There's no how you extend them, they will never meet. But the one that is oriented at a particular angle like this and this one, they will eventually meet somehow. So these ones are not parallel. I believe you get that. Okay, so we said that when two vectors are parallel, the dot product of the two vectors, that is the dot multiplication of the two vectors, will reach a maximum value. The reason why it is like that is because the cos 0 degrees, when they are parallel, no angle is formed. So we say theta is equal to 0. So cos 0 degrees, in trigonometry, when you press your calculator, the cosine of 0 degrees is always equal to 1. So if cos 0 degree is 1, then it means that A dot B is going to be equal to magnitude of A multiplied by magnitude of B and then multiplied by 1. Okay, but if peradventure cos theta happens to be a value like 60 degrees, for instance, okay, and then if you press your calculator, cos 60 degrees is going to give you a value that will it's going to give you half, all right, because sine 30 degrees is 0.5, all right. So sine 30 degrees and then cos 60 degrees will also give you the same value. Okay, so cos 60 degrees is 0.5. Is 0.5 multiplied by the magnitude of A and B. Okay, magnitude of A multiplied by magnitude of B multiplied by 0.5. That is going to be half of whatever value we get from the product of the magnitude. You get that? So if theta becomes a particular angle or any angle, okay, whatever is it will eventually multiply the result here and reduce the value. Okay, for instance, if cos theta is eventually maybe the two stuff forms 60 degrees, cos 60 degrees is half, and then that is 0.5. Then if 0.5 multiplies this, okay, at the end of the day, whatever it sits will cut to half of the value. So the more we get close to 0 degrees, then the greater the value of dot product. then at 0 degrees exactly, dot product reaches its maximum value because cos 0 degree is 1. And then 1 times this will be the full value instead of like a fraction of the value, which you get when you multiply by a decimal number. You get that? So if you don't understand, please rewind, or you can reach out to me, then I will explain to you in your own terms. You get that? Okay. All right, then we move. Number 2 point is that the dot product of two vectors is 0 when both vectors are perpendicular. Reason is that cos 90 degrees is equal to 0. So, but sine 90 degrees on the other hand is equal to 1. You get? So, but cos 90 degrees is 0. So since cos 90 degrees is 0, it means that by the time this cos 90 degree becomes 0, okay, if you know what we mean by perpendicular is that the angle between the two lines is 90 degrees. You have a line, a straight line, and then another straight line. The angle between them is 90 degrees. A totally straight line, like my hand now. The angle between this and this part, okay, is 90 degrees. So that is what we mean by perpendicularity in mathematics. So when two lines are perpendicular or two vectors are perpendicular, the angle between them is 90 degrees, and the cosine of 90 degrees in mathematics, in trigonometry, cosine of 90 degrees is 0. So now, which means this one becomes 0, and then 0 multiplied by everything here still becomes 0. So which means that the dot product of two vectors is equal to 0 when the two vectors are perpendicular to each other. Do you get? But it is maximum when the two vectors are parallel to each other. All these things usually come out in the exam, like in all those filling the gap questions and all that, okay? So they'll come useful. Then the next thing is the dot product is commutative, okay? Which means that if you experiment the dot product of A and B, like you find the value of A dot B, and then you decide to switch it over and then find the value of B dot A, you will eventually derive the same answer. You will arrive at the same answer. Dot product is commutative. And then the last point here is that the result of dot product is always a number. So anytime you solve question using dot product, you will always have number as the answer. So we have been able to, I believe we have been able to journey together in the theory part of dot product. So now in the next video, we'll solve a couple of questions with all that we have learned so far. All right, see you there. Bye.